Dear students, now I am going to explain refraction of light at curved surfaces part 3. So in this video, I am explaining image formed by lenses. So that means image formed by convex lens and concave lens. So convex lens can form 6 types of images at different places based on the position of the object, and a concave lens can form only one type of image irrespective of the position of the object. Now let us see image formed by the convex lens at a different position of the object. First one, so when object lies at infinity. So when object lies at infinity, object placed at infinity, light rays are coming from the object are always parallel to each other, and they are also parallel to principal axis. Now let us draw the ray diagram. So this is the convex lens and the principal axis passing through the optic center, and the parallel rays, they are parallel to principal axis. They are coming from the object placed at infinity. So they incident on the convex lens. So after refraction by the convex lens, so all these refract rays meet at one point on the principal axis, that is called focus. So that means, so when light rays are coming from the object at infinity, so they will form the image of the object at focus on the other side of the lens. So finally, when object placed at infinity, image will be formed at focus. So nature of the image, it is real image and point in size image. Now let us see second position. When object lies beyond 2f2, center of curvature, so an object placed beyond 2f2. Now let us see how image formed. So now let us draw the ray diagram. First I have to draw the convex lens, and this is the principal axis passing through the optic center. Now place the object AB beyond 2f2. So we have to draw the only two rays. So one ray is passing through the optic center, is undeviated. Let us draw another ray which is parallel to principal axis. So incident on the convex lens. After refraction, the refracted ray passing through the focus, and this refracted ray intersect the first refracted ray at one point. At that point the image formed. So finally, so when object placed beyond 2f2, the image A dash B dash formed between f1 and 2f1. Okay, when object lies beyond 2f2, the image will be formed between f1 and 2f1 on the other side of the lens. The nature of the image, it is real image, inverted, smaller in size. That means the size of the image A dash B dash is smaller than size of the object AB. Now let us see third position. When object placed at 2f2, center of curvature. Now let us draw the ray diagram, convex lens and principal axis. So now place the object at 2f2, and AB is the object placed at 2f2. So let us draw the light rays which are coming from the object AB. So first ray passing through the optic center is undeviated. Second ray which is parallel to principal axis, after refraction it is passing through the focus and it meets the first ray at one point. So the image formed at that point. So we conclude that if the object is AB, its image is A dash B dash. So when object lies at 2f2, the image will be formed at 2f1. So nature of the image, it is real, inverted, equal in size. That means in this case the size of the image A dash B dash is equal to the size of the object AB. Now let us see fourth position. When object lies between f2 and 2f2. So that means you have to place the object between F2 and 2F2, draw the ray diagram, convex lens, draw the principal axis. So now place the object between 2F2 and F2. So AB is the object placed between 2F2 and F2. So the light ray passing through the optic center is undeviated. So light ray which is parallel to principal axis after refraction passing through the focus. So both rays meet at one point. At that point the image is formed. So finally when object AB, its image is A dash B dash. So when object lies between F2 and 2F2, the image will be formed beyond 2F1. Okay. Now let us see fifth case. So when object lies at F2, now you have to place the object at focus. F2 means focus. Draw the ray diagram, convex lens, principal axis. So object AB placed at F2. So the light ray passing through the optic center is undeviated. Let us draw another light ray parallel to principal axis. After refraction, it passes through F1. So we observe that both refracted rays are parallel to each other. So that means they form the image at infinity. So that is when object lies at F2, the image will be formed at infinity. So the nature of the image, it is a real image, inverted and highly magnified. Highly magnified. So sixth case, so when object lies between F2 and O, O means optic center. Draw the ray diagram, convex lens, draw the principal axis. Now O is the optic center. Place the object AB between F2 and O. So light ray passing through the optic center is undeviated. Light ray which is parallel to principal axis incident on the convex lens. After refraction, it is passing through F1. We observe that these two rays are moving away from each other. So actually they do not intersect at any point. But when we extend these two rays in backward direction, so with the dotted line, they will meet at one point. At that point, the image is formed. So the image are formed at the same side of the object. So it is erect in nature. So it is the virtual image. So when object lies between F2 and O, image will be formed beyond F2 on the same side of the lens. So nature of the image, virtual, erect in nature and magnified. So these are the ray diagrams to explain the formation of images by convex lens. Similarly, we can explain the image formed by the concave lens also. So image formed by a concave lens. So concave lens always forms only one image irrespective of the position of the object on principal axis. So let us draw the ray diagram. This is the diagrammatical symbol for the concave lens, and draw the principal axis passing through the optic center. Now take AB object placed at any place on the object. So now I have placed between 2F1 and F1. So draw the light rays. So one ray passing through the optic center is undeviated, another ray traveling parallel to the principal axis incident on the concave lens. So concave lens can diverge the light rays. So actually these two rays do not intersect each other. So when extend the refracted ray to backward direction, so it will meet the light ray at one point. At that point the image is formed. So now your image is formed between F1 and optic center. So we observe that the size of the image is smaller than the size of the object. So it is erect in nature. So irrespective of the position of the object, a concave lens always produces a visual and erect image on the same side of the lens, which is smaller in size. Okay, thank you. So we'll continue remaining topic in next video.
Please do like, share this video and subscribe to our channel.